Hello students, in this video I'm going to show you how to solve the problems of exercise 2.3 of NCERT textbook of mathematics class 11. Okay, now you see this is the first question of NCERT textbook of mathematics of class 11 of exercise 2.3. okay, so which of the following relations are functions? Okay, give region. If it is a function, determine its domain and range. Here you see the first relation is this one. Okay, so let us write the given relation. Solution of the first one. It contains ordered pairs 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. Okay, so this is the relation. So now you see, if we observe each and every ordered pair, so we can see here the first component of its ordered pair is unique. Okay, so there is no two such ordered pairs having the same first components, so that's why it is a function. Therefore the given relation is function. The given relation is a function. Okay, because the first component of its ordered pair of the relation is unique. Okay, is unique. That is why it is a function. So what will be the domain of this function? So here domain of this function will be, so what is domain? The set of first first components of the ordered pairs. So 2, 5, 8, 11, 14, 17. Okay, so the domain must be 2, 5, 8, 11, 14, 17. Okay, this set is the domain. And what is the range? That is range of this function is, here you see, you can write here domain. Range of this function is what? Set of the second components of the ordered pairs. Okay, so what we have got in the second component? Only one. Okay, so here this is the range. Okay, so that's how we can solve the remaining two as well. So let us solve these two. Number 2, here you see, if you observe each and every ordered pair, the first component of each ordered pair is unique, like the first one. That is why it is also a function. Okay, it is also a function. And what will be the domain? Domain will contain here 2, 4, 6, 8, 10, 12 and 14. And what will be the range? Set containing 1, 2, 3, 4, 5, 6, 7. Okay, so let me show you here. First let us write the given relation. Okay, number 2. Here we have 2 comma 1, 4 comma 2, 6 comma 3, 8 comma 4, 10 comma 5, and 12 comma 6, 14 comma 7. So it is a function because the first component of each ordered pair is unique. Okay, is unique. No two ordered pairs here have the same first components, so that's why it must be a function. So what will be its domain of this function will be a set containing 2, 4, 6, 3, sorry, not 3, 8, 10, 12, 14. Okay, and range of this function will be set containing 1, 2, 3, 4, 5, 6, 7. Okay, so set of the second components. So here it must be 1, 2, 3, 4, 5, 6, 7. Okay, so this is the range. So that's how we can find domain in range. Okay, so hope you have understood this. Now let us check the third relation. Here you see this relation is not a function. Okay, this relation is not a function. This is not a function. Why? Because you see the first component of these two ordered pairs are same. Okay, both the first component of both is 1. Okay, so it is not a function. So let me write here. Okay, so let me clean this part. So here you see this relation here, number 3, this consists 1 comma 3 here, 1 comma 5, then 2 comma 5 here. Okay, so as you can see the first component of these two ordered pairs are same. This is also 1, this is also 1. That's why it is not a function. It is not a function because because 1 comma 3 and 1 comma 5 have the same first component. Okay, if it is not a function, then we don't need to find a domain in range, because it is mentioned here. If it is a function, then only we need to determine the domain in range. Okay, so that's how we can solve the first question. Okay, now let's move on to the next question, that is question number. Now let me show you how to solve the question number 2. Find the domain and range of the following functions. So here you see we have two functions here. We need to find the domain and range of these two functions. So let me solve one by one. Okay, so what is the first here? F of x is equal to minus mod of x. Okay, so here you see modulus of x is always positive. it is a non-negative real number. Okay, is a non-negative real number. Okay, so you see, that means if you put x equal to -2, then mod of x will be again 2. Okay, for x is equal to -2, mod of x will be, so mod of x will be +2. If you put +2, then also it is +2. If it is -2, then also it is -2. +2. Okay, so here that's why modulus of x, it is a non-negative real number for all values of x belongs to R. That means for any real number x. Okay, so that's why negative of positive integer is positive number is always negative, isn't it? Negative of any positive number is always negative. That's why here you see minus or negative of mod of x is always negative, always negative. Okay, therefore domain of this function f is what? R, and range of this function is always 0 to minus infinity. Okay, 0 to minus infinity. Okay, so that means here you see we will always get negative, or we can have you see f of x equal to 0 for x is equal to 0. In this case, if f of x is equal to minus mod of x, then for f of 0 we can have 0. And for any negative or positive numbers, suppose if you put +2, then we will get minus mod of 2, that is -2, isn't it? So here it is, you see this mod of x is always positive. That's why negative of it must be always negative. That's why we cannot get here positive numbers in the range. That's why range is represented by this interval from 0 to minus infinity. And the domain, as we can put any value here, any real number. Okay, there is no restriction. There is no real number for which this function is not defined. So it is defined for all real numbers. So that's why, that is why domain of this function is always a set of all real numbers. Okay, so this is the first one we have solved. Now let us find the domain and range of the next function, that is f of x is equal to root over 9 minus x square. Okay, so let me show you how to solve this one. So number 2, so solution, f of x is equal to root over 9 minus x square. Okay, now let me show you this. Here you see square root of any negative number, suppose root over -2. This is what? This is not a real number, it doesn't belong to R. Okay, so that's why in this case 9 minus x square must be greater than equal to 0. Okay, if so, then 9 must be greater than equal to x square. Okay, then you see you can write this one as well, like this as well. X square must be less than equal to 9. Okay, less than equal to 9. So now you see, we know that if x square is equal to 9, suppose x square is equal to 9, in that case x is plus minus root over 9, that is equal to plus minus 3. Okay, x is plus minus 3. So in this case x must be greater than equal to -3 and less than equal to +3. Okay, let me explain why. Now you see, this is the real number 9, this is 0, here it is suppose -3, and here it is +3. Okay, Now, as we have already mentioned here, 9 minus x square is always greater than equal to 0. Okay. Now, if you take any value which is less than minus 3, less than minus 3 means it may be minus 4. Okay. If you put here minus 4, then what you will get? Okay. F of minus 4 will be equal to root over 9 minus 4 square. That's going to be root over 9 minus 16. That's going to be root over minus 7. Okay. Which is not a real number. It doesn't belong to R. That's why it must be either greater than 3. That means it may minus 2, minus 1, or minus 2 point something. Okay. Or equal to minus 3. So value of x must be either greater than minus 3 or equal to minus 3. Similarly, suppose here you see, if you take any value of x which is greater than 3, if it is greater than 3, it might be 4, 5, like this. Okay, maybe 3.5, maybe 4.2. okay, so in that case also, if you put 4, x is equal to 4, then f of 4 that will be root over 9 minus 4 square. Okay, 4 square, which is equal to again 16, which is here you see root over 9 minus 16, again root over minus 7. Okay, which is also not a real number. It doesn't belong to real number. Okay, so here you see, in that case, so we have here already mentioned that 9 minus x square should be always greater than equal to 0. That means it must be a positive number. Okay, so we should not get here negative number. Okay, so for any value of x which is greater than which is less than minus 3, okay, and greater than 3, less than minus 3 and greater than 3, this term is not going to be positive. If we take x is x less than minus 3, okay, or if we take any value of x which is greater than 3, okay, greater than 3 means 3.1, 3.01, it may be 3.9, it may be 4, 5, 6, 7, etc. And less than minus 3 means minus 4, minus 5, or minus 3.6, such kind of values. Okay, so that's why we can take the values between this plus 3 and minus 3. Okay, plus 3 and minus 3, including minus 3 and plus 3 as well. Okay, and we can take real numbers between plus 3 and minus 3. Okay, that's why here domain must be the real numbers from minus 3 to plus 3. Okay, so let me clean this. Now let us find the range. We have already got the domain. Okay, now let us find the range. So in order to find the range, let us consider y is equal to f of x, which is equal to root over 9 minus x square. Okay, here you see, this is what? This is a positive number, root over 9 minus x square. So if plus minus is not mentioned before the root, that means it is a positive number. Okay, so because it cannot be negative, okay, as there is no minus sign before it. Okay, and square root of any negative number is not a real number, so there is no chance to be negative. Okay, so here you see, squaring both sides, we will get y square is equal to 9 minus x square, which implies y square is equal to 9 minus y square, x square is equal to 9 minus y square, and therefore x will be plus minus root over 9 minus y square. Okay, so x will be plus minus root over 9 minus y square. Okay, so here in this case root over 9 minus y square. We know that root of negative number doesn't belong to real number. That's why 9 minus y square must be greater than equal to 0. That means 9 must be greater than equal to y square, or you can say y square must be less than equal to 9. If so, then we know that if y square is equal to 9, then y must be plus minus 3. But in this case, as you can see, it is y square is equal to less than equal to 9. That's why y must be greater than equal to minus 3 and less than equal to 3. Okay, so then only this condition will be satisfied. Okay, 9 minus y square greater than equal to 0. Okay, this is possible only when y is greater than equal to 3 and less than minus 3, because I have already explained here in this condition that if 9 minus x square is greater than equal to 0, then yx is greater than equal to minus 3 and less than equal to 3. Let me tell you again. Here you see, if 9 minus y square is greater than equal to 0. Okay, now you see the 0, this is suppose 1 2, this is 3, this is 4, okay, this is 5. Okay, so here you see this is suppose minus 3, this is minus 4 suppose, and this is minus 2, minus 1, here is 0. So now you see this condition will be satisfied only for those values of y. Okay, only those values of y from minus 3 to plus 3. Okay, if you put a value beyond this interval, okay, beyond this limit, for y greater than minus 3 and y greater than plus 3 and y less than minus 3, 9 minus y square will be less than 0. If you put any values of y which is greater than plus 3, that means it may be minus 3, it may be 3.4 or 3.5 or 4 point something or 4.5, then this y square gonna be greater than 9. In that case, 9 minus y square will be less than 0. Similarly, if you take less value, if you take any value of y which is less than minus 3, that means less than minus 3 means it is minus 4, minus 5. Okay, then also value of y square will be greater than 9. Okay, on squaring these negative numbers will be again positive, isn't it? And 4 square is 16, which is already greater than 9. So in that case also this 9 minus y square will be less than 0. But in this case 9 minus y square is greater than 0. That's why only we can take these values of y. And again you see from here we can see it is a positive number. This is a positive number. Y is equal to root over 9 minus x square. It is a positive number. That's why so we cannot take the negative part of this. So that's why here you see, since y is positive, real number, so y is a positive real number, so the range of this function must be 0 to plus infinity. Here negative numbers should not be taken. This is the range of this function. Okay, so I hope you have understood this, how to solve these two problems, how to find the domain in range of these two functions. Okay, so now let's move on to next question. Now let me show you how to solve question number 3. Okay, so here you see a function f is defined by f of x is equal to twice x minus 5. Write down the values of f of 0, f of 7, f of minus 3. Okay, so it's very simple. You just need to replace the value of x by those values here. Okay, that's very simple. Let me show you one by one. Okay, so what is the first let us write the given function f of x is equal to twice x minus 5. Okay, f of x is equal to twice x minus 5. Now we are going to find f of 0. So how to find the f of 0? Now you see, when it is f of x, then it gives twice x minus 5. So if you replace this x by 0, then you will get, then here also this x must be also replaced by 0. Then 2 into 0 minus 5, that is 2 zeros are 0, 0 minus 5, that's equal to minus 5. Okay, so now number 2, we need to find f of 7. Okay, in order to find f of 7, replace this x, f of x, replace this x by 7, then this x will be also replaced by 7. So here you see, we must get twice x. Now instead of x there is 7, so we will have to write 2 into 7 minus 5. So 2 7s are 14, 14 minus 5, that's equal to 9, isn't it? So this is 9. That's how we can find f of minus 3 as well. Number 3, so f of minus 3, that's going to be 2 into minus 3 minus 5. 2 into minus 3, that's minus 6, minus 6 minus 5, minus 11. Okay, so that is your answer. So that's how we can find this 3. Okay, so hope you have understood. Now let's move on to next question, that is question number 4. Okay, so now this is question number 4. Here you see the function t, okay, which maps temperature in degree Celsius into temperature in Fahrenheit. Okay, defined as T of C. T of C is equal to 9C by 5 plus 32. Okay, so here we need to find T of 0, T of 28, T of minus 10, and then we need to find a value of C when T of C is 112. Okay, so now this is a function. Here you see T. Okay, this converts the temperature which is in degree Celsius into, it converts it into Fahrenheit. Okay, so let me show you, it's very simple. So here T of C gives 9C divided by 5 plus 32, isn't it? And the first one we need to find T of 0. Okay, it's like question number 3, just to replace the C. So if you replace the C by 0, then you will get here 9 into 0 by 5 plus 32. So that's gonna be 0 by 5 plus 32, that will be 0 plus 32, that's equal to 32. So that means 0 degree Celsius is equal to 32 Fahrenheit. Okay, that is 32 Fahrenheit. Okay, so now let me show you the next one, T of 28. Okay, T of 28. So T of 28, T of 28 is going to be equal to 9 into 28 divided by 5 plus 32 again. So here if you divide 28 by 9, 28 by 5, then what you will get, 28 by 5, 5 times are 25 here, that's gonna be 3 here, remainder is 3, so on decimal that is 35 6 are 30, so it's gonna be 5.6. so 5.6 into 9, 9 into 5.6 plus 32. Okay, so let me clean this first, then 54 5 carry 50. Okay, so 50.4 plus 32, that's gonna be equal to 82.4 Fahrenheit. Okay, so here 28 degrees Celsius is equal to 82.4 Fahrenheit. Okay, so hope you have understood this. So now let's find t of minus 10, number 3, t of minus 10, that's going to be equal to 9 into minus 10 by 5 plus 32. So 5 2s are 10 here, so 9 into minus 2, that's going to be minus 18 plus 32. Okay, that's going to be equal to 14. So that means minus 10 Fahrenheit is equal to 14 minus 10 degrees Celsius is equal to 14 Fahrenheit. Okay, so now we need to find the value of C, this value of C. Okay, value of C when T of C is equal to 212. Okay, so let me clean this part. So what I have done here, so then I'm gonna show you how to find the C when T of C is given. Okay, so let's clean this part. So when T of C is equal to 212, then so we have got here T of C is given, this one, that is 9C by 5 plus 32, isn't it? 212, then 9C by 5, so 212 minus 32, that's going to be equal to here 180. Yes, 180. So now C must be equal to 180 into 5 by 9, isn't it? 9 this is 100. So now value of C is 100 when T of C is equal to 112. So that's how we can solve the fourth of question number 4. Okay, so now let's move on to next question. Okay, that's question number 5. Now let me show you how to solve the question number 5 here. You see, find the range each of the following functions. Okay, we need to find the range only of these functions. Okay, so let me show you one by one. So what is the first one here? F of x is equal to 2 minus thrice x. Okay, where x belongs to R, that means it is a real number such that x is greater than 0, that means it is a positive real number. Okay, so what can be its range? In order to find the range, let me consider let y is equal to f of x. Okay, so then y must be equal to 2 minus thrice x, because f of x is equal to 2 minus thrice x, isn't it? So it implies let's bring a minus 3 to this side, then it will be plus thrice x on the other side, 2 minus y. So thrice x is equal to 2 minus y, so that's why x gonna be equal to 2 minus y divided by 3. Okay, so here you see, so what are the values, possible values of y here? Here you can see, as x is greater than 0, it is already mentioned in the question, that's why 2 minus y by 3 must be greater than 0. Okay, and that implies 2 minus y must be also greater than 0. Okay, then it must be also greater than 0. Okay, which implies 2 is greater than y minus y on the other side, or you can say like this, adding y on both sides, then we will get 2 greater than y, or we can write y less than 2. If 2 is greater than y, then we can say y is less than 2. Okay, y is less than 2, that means we can take any value less than 2. Okay, therefore range of this function must be from plus 2 to minus infinity. Okay, this interval represents the set of real numbers less than 2, from less than 2 to minus infinity. Okay, So here 2 is not included because y is less than 2, not less than equal to 2. It is less than 2. That's why here also open interval. It is completely open interval from both sides. Okay. So let us take the next function, that is f of x is equal to x square plus 2, where x is a real number. Okay. So in order to find the range of that, let me clean this page again. So it's so the next function is f of x, where which is equal to x square plus 2, where x is a real number. X is a real number. Okay. So this is the next function, number 2. So here you see, in order to find the range, let us consider y is equal to f of x. Okay, so y must be equal to x square plus 2. So that's why here x square must be equal to y minus 2. Then x square is y minus 2. That's why x must be equal to plus minus root over y minus 2. Okay, x must be equal to root over plus minus y minus 2. Now you see, if it is root over y minus 2, then inside the root there must be positive number. Okay, so that means y minus 2 must be greater than equal to 0, either equal to 0 or greater than 0. So in that case, y must be greater than equal to 2. So if the value of y may be equal to 2 or greater than 2, that's why range will be given by r of f from plus 2 to plus infinity. So here you see, it is here I am using close interval at the end of 2 here, because 2 is included here, because y is equal to 2 or greater than 2. So y equal to greater than equal to 2. So that's why this is the range of this function. So now let's move on to next function. Okay, that is question the third function. Okay, let me clean this one again. Okay, so what is the third function here? Number 3, f of x is equal to x. So now you see, if f of x is equal to x, then also it is given that x is a real number. Okay, x is a real number. So if f of x is equal to x, so that's and x is a real number, here domain must be real number. So and it will be defined for all values of x belongs to R. So that's why range must be again R. Okay, range of this function must be R, means set of all real numbers, because here you see, if you consider y is equal to f of x, then you will get y is equal to x. Okay, if y and x both are same, then function of this here you see, and x belongs to R, then the you see, range of this function must be set of all real numbers, because why, let me tell you again, because y is equal to x, y is equal to x. Okay, so and x belongs to R. Okay, so range of this function must be R, which represents set of all real numbers, set of all real numbers. So it is the last question of this exercise, exercise 2.3 of NCERT textbook of mathematics. So this exercise is completed now, and so I have taken additional question here which is not included in the textbook of mathematics of NCERT of class 11. Okay, you see, for better understanding about function, how to find the domain and range, those questions which are given in this exercise are not enough. Okay, that's why I have taken those additional questions. So now here you see we need to find the domain and range of these functions. Okay, so let me show you one by one. So first of all, let us take the first one. What is the first one here? F of x is equal to root over 1 minus x square. Okay, so what will be its domain then? Here you see I have already told you that minus sign, sorry, this under root, there should not be negative number. If there is negative number, then it doesn't belong to real number. Okay, so that's why we cannot take here negative. Okay, that's why this 1 minus x square must be greater than equal to 0, either greater than 0 or equal to 0. Okay, so here you see this implies 1 is greater than equal to x square, or you can write x square is less than equal to 1. Okay, if 1 is greater than equal to x square, then x square must be less than equal to 1. Okay, if so, then x must be greater than equal to minus 1, less than equal to plus 1. Okay, so remember one thing. Suppose you have a number, remember one thing. If, look at this, if x square is less than equal to 1, then we can write x is greater than equal to 1, greater than equal to minus 1, less than equal to plus 1. Okay, here you see, because x square is equal to 1, then x must be equal to plus minus 1, isn't it? So here x must be greater than equal to minus 1, less than equal to plus 1. But suppose if you have x is, instead of less than equal to 1, greater than equal to 1, suppose you have x square is equal to greater than equal to 1, then what will happen? Then you have to write x is less than equal to minus 1 and greater than equal to plus 1. Okay, so then that means this implies x is less than equal to minus 1, greater than equal to plus 1. Okay, so hope you have understood. X must be either less than equal to minus 1 or greater than equal to plus 1. Okay, in this case only, when x square is plus 1. Let me give you some more examples. Suppose you have x square is less than equal to 4. We know 4 is 2 square is equal to 4. So here you see 2 square is equal to 4. So x, in this case, x must be greater than equal to minus 2, less than equal to plus 2. Because if you see, if x square is equal to 4, then x must be equal to plus minus 2, because root over 4, it must be plus minus 2 means plus minus root over 4, isn't it, which is equal to 2. Okay, so if x square is less than equal to 4, then x must be greater than equal to minus 2, less than equal to 2. Instead of less than equal to 4, if x square is greater than equal to 4, then what to write? Then x is less than equal to minus 2 and greater than equal to plus 2. Okay, either less than equal to minus 2 or greater than equal to plus 2. Okay, let me take some additional questions. Okay, now let's come to the question again. So I have cleaned this word. Okay, so now here you see, from this interval we can clearly say that domain of this function d of f means df means domain of this function f. Okay, so this must be close interval minus 1 comma plus 1. Okay, so because minus 1 and plus 1 are included here, so this is the domain of this function. Okay, so hope you have understood. Now let me show you how to find the range of this function. Okay, so in order to find the range, let us consider, let y is equal to f of x. Okay, let us consider y is equal to f of x. We know f of x is equal to root over 1 minus x square. So that's why y must be equal to root over 1 minus x square. Okay, so y is equal to root over 1 minus x square. It is a positive value. Okay, remember this one, it is positive number. Okay, so let us square both sides. We will get y square is equal to 1 minus x square. Okay, this implies x square is equal to 1 minus y square. Okay, if x square is equal to 1 minus y square, then x must be equal to plus minus root over 1 minus y square. Okay, so here you see from this part should not be negative. Okay, this should not be negative, so that's why we get 1 minus y square must be greater than equal to 0. If so, then it implies 1 is greater than equal to y square, and hence y square is less than equal to 1. Okay, y square is less than equal to 1. So if y square is less than equal to 1, then y must be greater than equal to plus 1 less than equal to 1. Okay, so I have already told you that y is equal to root over 1 minus x square. It is a non-negative number. So as y is a non-negative number, that means it is positive number, non-negative real number. Therefore the range of this function must be from 0 to 1. Okay, so y can be equal to 0, then as I have already got here, y is less than equal to 1, so 1 is also included here. Okay, this is the range. And as y is a non-negative number, though we have got y is greater than equal to minus 1, but we cannot take that values greater than equal to minus 1. Okay, so therefore our range of this function is this one, from 0 to 1. Okay, so this is the range. That's how we can find the domain and range of such functions. Okay, so let me show you the next one. So now let me show you the next one, that is f of x is equal to root over x square minus 4. Okay, so here number 2, f of x is equal to root over x square minus 4. Okay, so what will be its domain? So again, x square minus 4 must be greater than equal to 0, isn't it? So if so, then x square must be greater than equal to 4. So I have already told you that here you see x square is equal to 4, then if x square is equal to 4, then x is equal to plus minus 2, isn't it? Okay, so if x square is equal to greater than equal to 4, then in this case x must be greater than equal to in this case x must be less than equal to minus 2 and greater than equal to plus 2. If x is less than equal to 4, then x must be greater than equal to minus 2, less than equal to plus 2. Okay, so remember these points. Okay, so now here you see this is x square is greater than equal to 4, then we have to use this one. X is less than equal to minus 2, x is less than equal to minus 2, and greater than equal to plus 2. Okay, so therefore the domain of this function must be equal to what? Domain of this function so domain must be equal to set of real numbers minus open interval minus 2 to plus 2. Okay, so because you see, so if you put any value of x which is greater than minus 2, maybe minus 1 point something or -1 0. Okay, then what will happen? X square minus 4 will be equal to, suppose we have taken here -1, which is greater than -2, isn't it? So -1 square minus 4 will be what? 1 minus 4, that's equal to -3. So we have got -3, which is less than 0. Okay, but we have already mentioned here that x square minus 4 is greater than equal to 0. Okay, x square minus 4 is greater than equal to 0. It should not be less than 0. Okay, again similarly, if you put values which is less than 2 means it may be 1, maybe 1 point something. So let us put here x less than 2, let us put here 1. Okay, any value less than 2. Okay, if you put 1 here, 1 square minus 4, then again 1 minus 4, that's going to be equal to -3, which is again less than 0, but it should not be less than 0. It is equal to greater than equal to 0. So that means here you see the values between 2 and -2, okay, of the real line here, real number line, suppose values between 2 and -2. Okay, these values between 2 and -2, okay, those values, those real numbers cannot be the elements of the domain of this function. Okay, so that's why the domain is set of real numbers minus this interval, open interval from -2 to +2. So why I have written here open interval? Because you see x is less than equal to -2. Okay, -2 is included, and x is also greater than equal to +2. Okay, so x can be equal to -2 or +2. Okay, so that's why let me clean this a little bit. That's why this domain must contain -2 and +2. Okay, so that's why these two should not be removed from this domain. So that's why here you see I'm using open interval from -2 to +2, means these two elements -2 and +2 are not in the set represented by this interval. If they are not in this set represented by this interval, then they must be in this set. Okay, they must remain in the set of real numbers. Okay, so hence they are also exist in the domain of this function. Okay, so now let me clean this one, then let me show you how to find the range of this function. Okay, let's find the range of this function. So in order to find the range of this function, let me consider this one. Y is equal to f of x. Y is equal to f of x, and f of x is equal to x square minus 4, isn't it? So y must be equal to root over x square minus 4, root over x square minus 4, and this is definitely positive because there is no minus sign, so it must be positive here. So squaring both sides, we get y square is equal to x square minus 4, and which implies x square is equal to y square plus 4, and again it implies x is equal to plus minus root over y square plus 4. Okay, so again here you see y square plus 4 should not be negative, it must be greater than equal to 0. Okay, it must be greater than equal to 0. Okay, so I have already mentioned here that if y is equal to root over x square minus 4, so this cannot be negative. Okay, so there is no minus sign here, so that's why it must be a positive number, and to be in the set of real numbers, so inside the not inside, under the root there should not be negative integer as well, and there is no chance to be negative this negative value of this expression root over x square minus 4. And here you see, so what will be the range of this function then? Range of this function. So as you can see, this should not be negative. Y square minus 4 should not be negative. So and y is a non-negative number, it is already positive integer. Okay, y is a non-negative, not integer, and non-negative real number. Okay, suppose real number. Okay, so then for any value or any positive value of y, this expression will be definitely greater than 0, or yes, greater than 0. Y cannot be negative. So that's why the range of this function must be equal to a set containing from y equal to 0 to plus infinity. Okay, plus infinity. So the set of range is represented by this interval. This includes 0 up to infinity, positive infinity. So this is the range of this function. Okay, so hope you have understood this, what is how to find the range of this function. Okay, so now let me show you next one, that is f of x is equal to root over x minus 1 into x plus 3. Now let me show you how to find the domain and range of this third function, f of x is equal to root over x minus 1 into x minus 3. Okay, let me show you how to solve this. Okay, so here f of x is equal to root over x minus 1 into x minus 3. Okay, x minus 1 into x minus 3. Here you see, so it will belong to R, it will belong to R if x minus 1 into x minus 3 is greater than equal to 0. Okay, otherwise this value cannot be a real number. Okay, so that's why it must be greater than equal to 0. Now here you see, in this case it will be greater than equal to 0 if x minus 1 and x minus 3 both positive or both negative, and it will be equal to 0. Then if any one of these two equal to 0, either x minus 1 equal to 0 or x minus 3 equal to 0. Okay, now you see why here both of them, either both of them must be negative or both of them must be positive. Here you see, here product of these two must be greater than equal to 0. That means their product must be positive. Yes, so we know that positive into negative is negative, isn't it? So that's why again negative into negative is negative, isn't it? Sorry, positive. So that's why here you see, to be positive, to be greater than equal to 0, either both of them must be positive or both of them must be negative, then their product will be positive. Now you see, x minus 1 will be negative, this x minus 1 will be negative if x is less than 1. Okay, and x minus 3 is negative when x is less than 3. Okay, here you see, for the values between 1 and 3, okay, for these values of x, if x is you see less than 3 and greater than 1, okay, that means it may be 1 point something or 2 point something. Okay, for those values, this x minus 1 will be positive, x minus 1 will be positive, but x minus 3 will be negative. Okay, in this case, for these values, for this interval which is for which x is greater than 1 and less than 3, in this interval x minus 1 is positive, x minus 3 is negative. Okay, if one of them is positive, other is negative, then this cannot be greater than equal to 0. Okay, it cannot be greater than equal to 0. That's why we cannot take the values of this values of x between 1 and 3. Okay, so the set of numbers represented by this interval, okay, that is open interval 1 to 3, okay, those numbers cannot be the value of x in this case. Okay, so in that case, what will be the domain? Domain of this function will be, so let me write in other color. Domain of this function will be set of all real numbers minus 1 comma 3. Okay, so minus 1 comma 3, that means the numbers represented by this interval, the numbers in the set represented by this interval should not be included. Okay, so this is the domain of this function. Okay, so this is the domain of this function. Let me show you how to find a range. Okay, so let me clean it first. So in order to find the range, let me consider y is equal to f of x. Okay, so which means y must be equal to root over x minus 1 into x minus 3. So here you see this y is positive here. Okay, so I have considered y is equal to this. Now squaring both sides, we'll get x square, y square is equal to x minus 1 into x minus 3. Okay, and product of these two must be x square minus 4x plus 3. Okay, so from here let me find the x now. Okay, so how to find it? Now you see, shift the y square to other side of the equation, then what you will get? X square minus 4x plus 3 minus y square is equal to 0. Okay, so then here you see, you can consider this part as constant, then you can consider this one as a quadratic equation, isn't it? So then, so the value of x must be equal to, so here I have to apply the quadratic formula. Okay, minus b plus minus root over b square, that is here minus 4 square minus 4ac, that is a is 1, c is, consider this one as c, 3 minus y square divided by twice a, that is 2 into 1 here. Okay, so let me simplify this. That's gonna be equal to 4 here plus minus root over, so let me write here, it will be 16 minus 4 square 16, and here minus 4 3 is a 12 here, then minus plus 4 into y square 4y square. Okay, divided by 2. So here we will get 4 plus minus root over 4 plus 4y square divided by 2. Now you see, this part under root must be greater than equal to 0. Okay, greater than equal to 0. Okay, it should be greater than equal to 0, but here it will be only greater than 0, because you see, if here 4 minus 4y square is equal to 0, then in this case, if you put here 0, then in this case x will be equal to 4 divided by 2. Okay, that's gonna be equal to 2. Okay, 4 divided by 2, that is 2. So here in the domain we have seen here that this domain, here you see, this domain doesn't contain 2. Okay, So that's why value of x cannot be equal to 2. Okay, R is the set of real numbers, and this interval 1 2 3, okay, it contains value greater than 1 and less than 3. So definitely 2 exists here, as this is here you see this is excluded from this set of real numbers. So that's why 2 should not be in this domain of this function. Okay, so that's why we cannot take here 4 plus 4y square equal to greater than equal to 0, only greater than 0. Okay, remember that. So now here you see, in this case 4 plus 4y square, y square, doesn't matter what is the value of y, it always going to be equal to, sorry, greater than 0. Okay, and here we have already got that here you see, if you observe this is a positive number. Okay, this is a positive number, so y definitely greater than equal to 0. Therefore the range of this function must be from 0 to infinity. Okay, so range of this function is given by this interval. Okay, set represented by this interval. So this is the range of this function. That's how we can find the range and domain of this function. Okay, hope you have understood. Now let's move on to next one. Now let me show you this one. F of x is equal to ax plus a plus x divided by a minus x. So here f of x is equal to a plus x by a minus x. Okay, so here you see, for x minus a minus x is equal to 0, this f of x is not defined, because if a minus x is equal to 0, then a plus x by a minus x will be not defined. A plus x will be divided by 0 is not defined. Okay, so that's why a minus x cannot be equal to 0, hence x is not equal to a. Okay, so a minus x is not equal to 0. That's why what, x cannot be equal to a. Okay, if x is equal to a, for this a minus x will be 0. Okay, and in that case fx will be not defined. That's why x cannot be equal to a. So value of x can be any real number other than a. So that's why its domain of this function must be set of real numbers minus set containing element a. Okay, so this is the domain of this function. Okay, now let me show you how to find the range. Okay, so let me clean this. Now let us consider y is equal to f of x. Okay, which implies y is equal to a plus x by a minus x. So now you see, let me simplify this. That's gonna be a y minus yx a plus x. Okay, so here transfer this one to other side, then x plus y x, and bring this one to this side, then y a minus a. So here x into 1 plus y, so a into y minus 1. Okay, so then x must be equal to here y a into y minus 1 by 1 plus y. Now you see, it cannot be here you see, this denominator cannot be equal to 0. So 1 plus y is not equal to 0. Okay, when it will be 0? When y is equal to minus 1. For y is equal to minus 1, for y is equal to minus 1, 1 plus y will be equal to 0. Therefore the range of this function r of rf, range of this function must be r minus set containing minus 1. Okay, this is the range of this function. So now let's move on to next question. So our next function is f of x. is equal to x by mod x. Okay, so here you see f of x, this is the number 5th. Okay, f of x is equal to x by mod of x. Okay, so here you see in this case also mod of x cannot be equal to 0, it cannot be equal to 0. Okay, so that's why here its domain of this function must be R minus set containing 0 as element. Okay, then what will be the range? How to find the range? So let me show you how to find the range. So here you see f of x is equal to x by mod x. Okay, which also can be written as x by x or x by minus x. Okay, in this case if x by x, then it will be 1, and x by minus x will be minus 1. It doesn't matter what is the value of x. Okay, it doesn't matter what is the value of x, it always going to be either plus 1 or minus 1. Okay, so here you see, now you see mod of x. So in this case x, value of x can be positive or it may be negative, both. Okay, so because here you see mod of any real number, suppose mod of plus a or minus a is any real number, it's always gonna give you plus a. Okay, so that's why, that's why f of x either equal to x by x, which is equal to 1, or x by minus x, which is equal to minus 1. Okay, it doesn't matter that what value you put, what value of x you put here, it's always going to give you either 1 or minus 1. That's why range of this function must be 1 and minus 1, set of only these two numbers. That is the range of this function. Okay, hope you have understood. It's very simple. Okay, here I have forgot to mention one thing here. This will be 1 when x greater than 0. Okay, and it will be minus 1 for or when x is less than 0. Okay, so let's move on to next question. So our next function is f of x is equal to x square minus thrice x plus 2 by x square plus x minus 6. Okay, so let me take this function. Okay, solution. So here f of x is equal to x square minus thrice x plus 2 divided by x square plus x minus 6. Okay, so if we factorize these two polynomials, these two quadratic polynomials, we will get x minus 1 into x minus 2. Okay, by x plus 3 into x minus 2. So I'm not going to show you how to factorize this, because in class 10 you have already learned how to factorize quadratic polynomial. Okay, so that's why I have not shown here. So now you see here denominator cannot be negative, it cannot be it cannot be equal to 0. Okay, otherwise it will be not defined. That's why here you see x plus 3 is equal to 0 when x is equal to minus 3, and x minus 2 is equal to 0 when x is plus 2. So that's why for these two values of x, this is not defined. This is what this result is not defined. Okay, not defined. So that's why its domain of this function must be equal to what? Real set of real numbers minus set containing minus 3 comma 2. Okay, so this is the domain of this function. Okay, now let me show you how to find the range of this function. Okay, so in order to find the range, let us consider y is equal to f of x. Okay, f of x, so y must be equal to x minus 1 into x minus 2 by x plus 3 into x minus 2. So here you see x minus 2 cancel, so that's why y must be equal to x minus 1 by x plus 3. So let me simplify this. So yx plus thrice y is equal to x minus 1, which implies x minus yx is equal to 3y plus 1. So here x gonna be common here, 1 minus y, then 3y plus 1. So x must be equal to thrice y plus 1 divided by 1 minus y. So this is x equal to thrice y plus 1 divided by 1 minus y. Okay, here you see, from here you can see this denominator cannot be equal to 0. So here you see 1 minus y is not equal to 0 here. Okay, so 1 minus y will be equal to 0 if y is equal to 1. Okay, only in this case. So if 1 minus y is not equal to 0, then y should not be equal to 1. Okay, so y should not be equal to 1. Okay, now here you see what will be the range of this function. Now look at this first. What is the domain here? This is the domain of the function. So here x should not be equal to minus 3 and x should not be equal to 2. Okay, so here you see, if x is minus 3, then this y value is not defined. Okay, that means in this expression that we can say there is no value of y for which x is equal to minus 3. But there may be a value of y for which x can be equal to 2. Okay, because in this function you can see, if you put here x is equal to minus 3, this function is not going to be defined. Okay, it is not defined. Not defined for x is equal to minus 3. So here you see, but this expression is defined for x is equal to 2. This expression is defined for x is equal to 2, but we cannot take the value of x is equal to 2. Okay, if you look at the if you see the domain here, so 2 is not included in the domain, as this set is subtracted from the set of real numbers. Okay, so first let me find that for what value of y, for which value of y x can be equal to 2. Okay, we have already got that y is not equal to not equal to 1. Then we need to find, is there any value for which x is equal to 2. Okay, because x is equal to 2 is not included in the domain, that's why we cannot take the value of y for which x is equal to 2. So how to find for what value of x is for what value of y, for y is equal to what, x will be equal to 2. So in order to find it, let us put x is equal to 2 in this expression. Okay, in this expression. Okay, let us put here x is equal to 2. Okay, so we have already got that y is not equal to 1, as y is 1 minus y cannot be equal to 0, so y is not equal to 1. We have already got that. So let us put x is equal to 2 in, let us put x is equal to 2 in y is equal to in this expression. Okay, y is equal to x minus 1 by x plus 3. If you put here 2, then 2 minus 1 by 2 plus 3, that's gonna be 1 by 5. Okay, so for y is equal to 1 by 5, we get x is equal to 2, and x is equal to 2 doesn't belong to its domain. X is equal to 2 doesn't belong to its domain. Okay, domain of this function. So that's why we cannot take the value of y is equal to 1 and y is equal to 1 by 5. So what will be the range of this function? Then range of this function must be equal to r minus 1 comma 1 by 5. Okay, or you can write, let me write a lesser number, a smaller number first, 1 by 5 comma 1. Okay, so that is the range. Okay, this is the range of this function. Okay, so hope you have understood this, how to find the range and domain of this function. Okay, let's move on to the last function. So our last function is f of x, which is equal to 1 where x is a rational number, and it is equal to 0 when x is irrational number. Okay, so here it is given that f of x is equal to 1 when x is rational, and it is 0 when x is irrational. So here you see, since x may be rational and irrational both, okay, since x can be rational as well as irrational, okay, since the value of x can be rational as well as irrational, hence x belongs to R. Okay, x must be a real number, it may be rational or irrational. Therefore domain of this function is nothing but equal to R. Okay, this is the domain. And what is the range? It is clearly, you can see what is the range of this function. Range of this function will be 0 comma 1, because you see, doesn't matter what is the value of x. Okay, so only possible there are two possible values of fx, those are 1 and 0. Okay, if it is if the x is rational, then it is 1, if x is irrational, it is 0. So therefore range is the set which contains only these two elements, 0 and 1. So hope you have understood. So that's all about function, how to find the domain and range of a function. Okay, so in the next video I'm going to show you how to solve the problems given in the miscellaneous exercise of NCERT textbook of mathematics class 11. Okay.